Okay, welcome to a quick video about binomial distribution. This will be the first out of 2 videos where we talk about this. First of all, what is it and where do we use it? We use it for random experiments that can be done unlimited times, that have 2 outcomes, and where the probability stays the same. Okay, what does that mean? Can be done unlimited times just means you can repeat the process as often as you'd like. So for example, rolling a dice. You can roll a die for how long you like. You can always re-roll it. There's nothing to stop you. Then there has to be only 2 outcomes. Now with a die, there are 6 outcomes, right? There's the 1, the 2, the 3, the 4, the 5, and the 6. But we can kind of cheat around it. So for example, if we play a game and we say on a 6 you win. 6 is a win, and you lose on a 1 to 5. Then we can say, okay, this game has exactly 2 outcomes. Either you win or you lose. And then it doesn't matter that one thing has 5 numbers and the other thing only has 1 number. A 6 just means yes in this scenario, and a 1 to 5 means no. And this is how we cheat around it. Cheat around the 2 outcomes, even if you have an experiment that maybe has more than 2 outcomes. And the probability has to stay the same. So rolling a die, you always have the same probability to roll a 6. It doesn't matter if you roll a 6 before. Rolling a 6 always has the chance 1 over 6 because there are 6 numbers on the die and there's 1 6 on there, so it's 1 over 6 chance to get a die. So it's always how many things are there that you can roll, and then how many things you want to roll in order to win. So it's 1 over 6 this time, in this scenario. So where do we use it? Or what are we doing with it now? We now use it to determine the probability to win a certain amount of times in a certain amount of tries. For example, we play this game 4 times, and you want to win exactly 2 times out of the 4 times. So you are a good sport, and you want exactly that it's exactly half, that it's a that we have equal losses to win ratios, and you want a probability for that. So just a small heads up, there's also a way to calculate the probability of rolling a 6 2 times or more, or 6 2 times or less with 4 rolls. This will be the material for the next video about it. There will be 2 separate videos to have it in shorter videos. So what do we need for that? Well, first, of course, we need the probability to hit the 6 2 times. You want to hit it 6 times. So the probability, like we already said, is 1 over 6. Now we want to hit it 2 times, so it's 1 over 6 squared. If you don't know what the squared means, it's just this little power number, also called, is saying how often you multiply the number by itself. So 1 over 6 to the power of 2 means just 1 over 6 times 1 over 6. 1 over 6 to the power of 3 would mean 1 over 6 times 1 over 6 times 1 over 6. And we also say by to power of 2 squared. So this is just 1 over 6 times 1 over 6. Now we want to roll exactly 2 times. This is important. We roll exactly 2 times. So if we roll a die and we roll a 6 and a 6 in the first 2 times, then the other 4 rolls need to be not the 6. And whenever we calculate a number that is not, or a probability that is not a certain outcome, it is always 1 minus the probability of hitting that specific outcome. So the probability of hitting a 6 is 1 over 6. The probability of not hitting a 6 is 1 minus 1 over 6. And again, we want to hit it we want to not hit the 6 2 times. So it's 1 minus 1 over 6 times 2. To the power of 2, I mean. And then we need the amount of variation and order of the 4 rolls. So what does that mean? We already talked about you can roll the 6, then a 6, and then 2 4s, for example. But what if you roll a 6 and then a 4, then a 6 and then a 4? You still roll exactly 2 times the 6 within these 4 rolls. Or you can roll 2 4s and then 2 6s. So this just calculates how many different orders there are. And we already talked about it in the previous videos. If you don't, like if now the number that we calculate doesn't really, you don't really understand, then just watch the videos. And the number of variations are 4 choose 2. Because we have, can kind of, if you don't want to watch the videos, you can kind of just remember that it's the amount of rolls we have, or choose the amount of times you want to roll the 6. So it's 4 choose 2. And you can just hit it in the calculator and then calculate it yourself. So for this specific experiment, it would be 1 over 6 squared times 1 minus 1 over 6 squared times 4 choose 2. And this is your binomial formula. If you want to generalize it, it's first the probability of hitting this our yes. So probability, that's also called just P, is our probability to roll the yes, times how often we want to roll it. So we just say K times 1 minus P, because then again we want to not roll the outcome the other times. So if we roll it, for example, 5 times, and we want 3 times or K times the outcome 6, then we want 2 times the outcome not 6. Not 6 is again 1 minus P, the probability of that, and the amount if we roll it is 1 minus K. And wait, sorry, it's not 1 minus K. It's n minus K. And n just means how often we roll. So if you roll 5 times, it just means n is 5. And if you want to roll 3 6s, then K is 3. So here, for example, here really stands 4 minus 2, because we want to hit the 6 2 times, and the other 2 times out of the 4 rolls, we don't want to hit the 6. So it's 4 minus 2 here. and then it's n choose k for the variation of permutation. And then there's your binomial formula. This is used for very, very important things. Like it's used extremely often. It's really crucial to memorize this. But you can also always like get it back from a thought experiment. So I want you to understand how we got there. So this is like our probability times how often we want to have the outcome yes. Then this is our probability of no and how often we want the no, and we want the no as often as we don't want the yes out of our times that we roll. And then this is just the variation, where we have how many rolls we have and how many yeses we want, and then it's just the n choose k. Yeah, thank you for listening. So next time we will talk about using the binomial formula for rolling a 6 2 times or more, or 6 times or less. And I will see you next time. Also, please check out my streams if you want to, where I play strategy games. It's a little bit different than this, but it's still really fun. And I hope I will see you on my streams as well. And also there's a Discord channel. There's link in my information, also in the description of this video. And you can join the Discord via the link there. Thank you for watching, and I hope I see you next time. Bye bye.